Good morning, and welcome back to another episode of Making a Game. I've had another bit of a break, slightly longer than I'd anticipated, so we're going to have another little round of reminding ourselves where we're up to. But I think I remember, which is that we are able now to drop pieces and move them around a grid, but we can't rotate yet. Right, so we can move around, we can drop you down, pieces stick, and if multiple pieces fill lines, those lines get cleared. But you currently can't rotate, so I couldn't turn this to fit in that gap. Which I think means we're going to have to do a bit of maths. And I think subconsciously this is partly why I've been putting off coming back to this, is been a long time since I had to think through like vectory rotation type maths, but I've done a bunch of this sort of stuff before. I have a fairly mathsy background, so hopefully this is all going to be okay. So I think probably the thing to do is we draw a little diagram and try to work out actually what it is that we're going to need. So if I remember right, I think somewhere where we're updating our game, populate game entities takes in game update game. My goodness, do I even remember how this all works? What does game update game do? Game update, I guess, does our tick, does it? Okay, let me remind myself what our main loop's doing. While we should be running game update game. Each frame does a game update game. And then it handles events. And so presumably this is where all of our keyboard handling is. So we're in game, we're in keyboard. I hit these buttons. Alright, so we're going to need rotate on button presses. Which will do something similar to this update active piece position. Right, just instead of saying like I'm updating the position, I'm going to have to do some rotation, and that I think will involve updating position and other stuff like that. Yeah. That all seems reasonable enough. Our grid is just a long list of booleans at this point. So a space is either filled or not filled. And our piece is a hard-coded value. I can't remember hard-coded where exactly. Remember piece? No. I mean game? In game. Can I look for piece? There we go. The piece has a list of filled, which again is just a list of booleans that are either yes or no. These values are both 5 at the minute, so I'm imagining our little piece editor will allow you to make at most a 5x5 piece. Based on what values are in filled, we get our bounding dimensions that are then used for checking that you're in the grid and stuff. So you can imagine if I had like a 1x5 rectangle filled, the boundings in will be 1/5. So I think that we're going to add a sort of rotation center that we're going to rotate about in each piece. So if I grab a color, let's imagine we've got our piece. We'll use the little grid paper stuff like this. And we'll define a center of rotation like there. And then the behaviors we want is a rotation, the way around that is clockwise. The center of rotation won't move, and that horizontal becomes this way. Then we move the rest of this around. Get a piece like that. Our rotation counterclockwise, we do the opposite. So again, that point won't move. The up goes to the left. And the whole thing like this. Now, what I was saying about the bounding box moving is if we think, so if that's our piece, then this is our bounding box. And once it's moved, this is our bounding box, right? And bear in mind, this is the piece that doesn't move in the grid. So it has the same XY position at the start and finish. We'll notice that that means that this point and this point are different. So I think what this means is that on a rotation, we'll need to update our bounding position. Bounding box position. Like when our piece has a position, I think it's not on the piece struct itself because, again, we're thinking of this as being like an object that could come out of that piece editor. So I guess we have a game state instead. Game or game state? Yeah, there we go. There we go. So the game has a piece position. That piece position, I think we're currently using as... Whoopsie daisy. The wrong thing. I'm messing up my video. Hang on. Put you back where you were. That position I think I've been thinking of as being this bottom left position here. Which I think should work for us. So we need to update the bounding box position, kind of broadly the piece position. I think we need to update that filled Boolean. My God, my handwriting is terrible. Which hopefully makes sense, right? If we look at this one, this was true, 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 false, 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 true, false, false, false. And now it's true, false, 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 true, true, false, 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 right? So we need to map that. And I think what we'll do is just have the active piece actually do exactly that, right? We'll make a new piece struct with the updated filled values. Then we can use that for collision checking to check that the new position is valid. And I think in the first instance, if the updated position would be not valid, we just don't allow the rotation. Right. I think we can do that in either order. Is one easier than the other? That's a good question, right? Updating the filled stuff is maybe the place to start. In fact, I'll tell you where we'll actually start is with the handling the key presses. Because it's dead simple. Gonna be in here. I'm just gonna put them on my home row buttons, revealing that I'm a weird layout user. But I'm gonna put them under my index and middle fingers, which happen to be S and T. And then if I come back in here, I can say case. I think it looks like that. We will return that new stuff. And case. Oopsie daisy. GLFWET. Alright, so that we can now pick up those as key presses. Oh my God. Pen rolling all over the place. Given that, right, so that's the function that we actually register with glfw to write. So we have this kind of translation from the glfw event to an event in our event buffer, which we did just for kind of controllability sake. We then have somewhere a function that is handle game event, game handle event, which is where we put R to do. So in here else, if key event type is press and key event R is S. For now, we'll just print, so format print line on an S. Oopsie daisy, what's going on there? Format print line on an S, I want to rotate anti-clockwise. Vice versa for the key press. Cool. Let's just go ahead and check that. Oh, I'm an idiot. Do it from the right directory. Let's just check that worked. So everything's working as normal. And if I click my buttons, see in here that we get what we want. So that is working. Okay. Okay. They might just want to be separate functions, is what I'm thinking. The rotation logic, you know, like you could imagine we could do a generic rotation by an angle, but I think like we have a really simple problem, right, where we're going to be either 90 degrees one way or the other. Oops, that didn't do what I wanted. Okay. So, how would you map from our 5x5? Imagine here we're in this situation, and our things go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Right? How does that map to rotate clockwise? Right, so we're going this way around. It means that this is our new bottom, right? And this corner is moved to here. So we go 0, 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, 11, 12, so on. So we can now copy the values across, and right, so if we just index into this one, we say for each of these, I can find what column and row I should be in and write that, and I guess it'll be useful to have the counterclockwise version as well. Oh my god, I'm hitting buttons I don't mean. I'm not convinced I like this pen thing. Maybe I do. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we counterclockwise rotate, we think about the same issue. Going counterclockwise, this 0 moves to this side. Right, the 4 moves to the top. Now 0, 1, 2, 3 that way. Seems right. And 5, 6, 7, 8. I think the easiest thing to do is to just write those as two separate functions. Yeah. Let's go with that then. Pen is rolling. Put that there. So, what do I want to say in here? Update active piece position. You are taking in a game state. I assume that's a pointer. Yeah, because otherwise you wouldn't be doing the updates. Okay, let's say here, do anti-clockwise. Rotate active piece anti-clockwise. Taking in the game state. This one can rotate active piece clockwise. Taking a game state. Right, let's go. Let's define it next to this. Rotate active piece clockwise. It's going to be a proc that takes in a pointer to the game state so we can update it. Current returns nothing, and again, format print line clockwise and rotate active piece anti-clockwise. Game state, pointer to game state. God, anti-clockwise. Run it. And yep, so it's still running everything. Cuckoo, cuckoo. So there's going to be a position update. If we just don't worry about that, if we just update the filled stuff, we essentially get a rotation about some point inside the shape. So I think we can do that and see that it's working. Alright, so let's start with the clockwise. And what we'll say... I think game state has a piece on it. Bounding dim will just be flipped, right? If we look at our example, like, I think it's obvious. Whichever way around you rotate this by 90 degrees, the width becomes the height, and the height becomes the width. I think we can just do that trivially. So the bounding dim becomes a, oh my god, what's it called? Grid dim, where the width is equal to game state, active piece, bounding dim, height, and the height is game state active piece. Bounding dim dot width. Let's rearrange that for readability. Filled is the more interesting one. I guess we just leave 0 initialized for now. And then we go here and we'll say for value and index in game state dot active piece dot filled. Right, so this will give me the true false and that 0 through 24 index. And what I want to do is I want to find these values, right? Oops. So when I have 0 here, I want it to give me this index, which will be 5, 10, 15, 20. How do we do that then? So the column I'm in, I'm switching the rows and columns basically, aren't I? Oh, it's too early in the morning to be doing this. I can work it out from the index. I'm sure of that. So can I say col index? Or it's like right col index. Given the index I'm putting in, I'm going left to right, so it'll be increasing. And I can get it by just dividing index by grid width. Right, so I'm in column 0, while index number divided by 5 is it rounds down to 0. Then once it rounds down to 1, I'm in 2, then 3, then 4. Oh, sorry, so I should really be saying like column 0, column 1, column 2. Yeah, that makes sense. And then the row I should be in, we call it the right row index. Would be this, except that the sign, it will be going the wrong direction. I think what I actually want is grid width minus that value. Does that sound right? So if I'm number 7, I divide by 5, I get a value of 1, so I know I'm in this column. I then say the remainder would have been 2, and I go 5 minus 2 is 3, so I'm at position 0, 1, 2, 3. No, out by 1. Is that true? Yeah, because index modulo grid width can be 0, which would give me a value of grid width, but this is bounded by 1, so actually, or it's non-inclusive. I go from 0 to grid width minus 1, so I have to take 1 off there. If I put in 7, the modulo gives me 2. I do 5 minus 1 is 4, minus 1, sorry, minus 2 gives me 2, and then I come in here and I go 0, 1, 2, and find 7. 8 would have given me a modulo of 3. 5 minus 3 is 2. So you do 5 minus 1 minus 2. All right. I put in 8. That value is 3. So 4 minus 3 is 1. Yep, there you go. So it moves it down. Goodness gracious. Making a meal of this. We can then come in here and say updated piece dot filled at right col index times grid width plus right row index is val. We could actually, because we know that this is 0 initialized, we could just skip over the vowels, but our piece grid, I think, will get more complicated in future. So that 0 initialized state isn't necessarily going to be a given, so let's be more explicit about it. There's no pain in being explicit like this. So we do that. And then I think in real life, there'll be some checking in here to check that the updated piece actually fits. But if we then just take that and we say gamestate.active piece is updated piece, and we go run this, we blow up. Index 29 is out of range, 0 to less than 25. In here. Right, let me do a debug print before we whip the debugger out. So if we go format print line, we'll take the index that's going in, and we'll take right col index and right row index. Let's see what values it's spitting out. So 0 gives us 9. Grid width Grid width is 10. Ah, it's because I'm saying grid width, not piece width. Yeah, Egypt. Alright, let's try that again. Here. Okay. We are outputting something. And we're no longer crashing. But nothing's happening. So let's just look at one of them. It goes from 0. Yeah, so 0, 0. So this value is 0, 0. And I'm getting a value of 0, 4. Is 0, 4, as expected. And we see it then goes 0, 3, 0, 2, 0, 1, 0, 0, 1, 4, 1, 3, 1, 2, 1, 1. Okay, so that looks like I expect it to. 10, 2, 4, 2, 3, 2, 2, 2, 1, 2, 0. Cool. So why is that not updating anything? I think this will update our game state. I think we're getting to a world that's maybe overcomplicated now. What we have is a game state that represents the state of the game. We do all our updates on that. We do all our logic against that. Then we have an entity which represents the thing on the screen, which I think I introduced because it made it easy to get hold of stuff for mouse controls, because that cares about the position on the screen rather than the position in like an abstract sort of sense. Then the entity, so the entities get generated from the game state. Then the entities generate drawables, which lose all the information about what the things are and just has information about what they look like and where they are. And that then generates the indices and vertices that get sent to the GPU. So the problem here must be in how we're dealing with entities, right? Because it's a behavior problem. I think it must be in here. Entity push, grid entity. Oh, okay, let's go back to main. I think I've had a thing on my to-do list for a while to go through and tidy where all these different functions are, because they've all just kind of ended up all over the place. Right. Populate entities. We're in the game. We have grid, which has active piece in it there. Interesting. So what I was kind of expecting to see somewhere in here is that we weren't using the active piece on the game state. We have a hard-coded one sat somewhere that maybe I'd lazily just use that, but no, this is pushing a grid entity from the active piece, and that active piece is hopefully used in here somewhere. If has active piece. Yeah, there you go. All the values in filled. Curious. Have this just format print line. So what function am I in? Grid entity. Oh, it's not got a format imported yet. And I think I would also like to go back and remove my other format print lines. Or at least comment it out for now, because I think it's going to make noise. Right. So I go ahead and do like that and close. Oh, we're spamming all sorts. Come down here. Okay, we can see our bounding box is still 5-3. Oh no, the bounding box is flipping. But our filled value is not changing. Active piece filled. So there's a big block of... Oh my goodness. You see how it starts with a big block of trues? That's because it's a completely filled grid in that bottom half. So we'd be expecting to see... what would we be expecting to see? We'd be expecting to see like true, 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 false, false, true, 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 false, false, as it turns to a completely filled thing in the other direction. Why aren't you working then? Game state active piece equals updated piece. Data. Grid entity data. Cells equals filled grid. What is that? Go call this. Yeah, the grid just lives on the game state. Okay. So that's why that's being passed in there. And then we're updating the values in that grid based on the values in active piece. So if active piece is being updated as expected, then we'd expect to see something happen. Right. What am I missing? This feels like it's probably actually like embarrassingly obvious, doesn't it? Game state active piece. Alright, so let's go ahead and say rotate clockwise old active piece. You can't have active piece there, right? I'm not using anywhere. Okay, yeah, they were just being slow. Oh, I was missing something daft then. Alright, so format, print line. This one here is rotate clockwise. Then updated active piece. Old active piece. Okay, good. We know for a fact that what? I've done this backwards, haven't I? Which row you're in should get shifted by the piece width. Which column you're in is just like the left-right. Oops. Hey, there we go, boys. Excellent. I think this is going to show the problem. Yeah, so remember I was saying that we're going to have to displace our what's it? Bounding box. The bounding box for this is still, it's now a 5x3, but it's still, it thinks its position's down here, and so the collision detection's all over the place. But we are now rotating. That was a silly one, wasn't it? Let's bin that. Now then, I think we're going to do a bit of dumb copy pasting in here. Because there's not that much to it at this point. And all the interesting stuff's in that loop, and that's going to be different. So the updated piece, bounding, this line is literally this line. So let's... Does that yoink a line? I think it does. Oh, it yoinked everything. I'd be like, I want that. Then we're going to say for value index in game state active piece dot filled. Do the thing, and then active piece equals updated piece. This is the bit that's going to be different. So my right col index, we go back to our diagram, we're now going right to left and top to bottom. So the same kind of thing that we did before here. Although I'm going to make a point that the row index decrease from height, won't it? So currently height and width are the same. They might stay the same forever, but I think that's the actual value we want. Whereas col index will be piece width -1 minus... Hang on, thinking. So, given an index, I want to go from right to left. I care... I want them to stay in that column for a few of them, so it isn't that, it is this. Sorry, it is... My god, typing. It is a division. Right, so it'll stay there for a bunch in a row. And right row index is going to change. As I increase the index, I expect this one to go up to a maximum, then resets. This will be the modulo. And it goes from bottom to top. It can just be index modulo. Oh, is that right? I'm so mixed up about which one's height and which one's width now. And again, the values are currently the same, so it doesn't matter. But... Right, so... If I have some index, I divide by the piece width to work out which row in the input I'm in. And then I want to go in my output. Yeah. And then this one here, I need to know where within the row I am, so it's still going to care about the width. And why does this one want to be height? To my right column index is because this is related to the position I am in the output, which cares about the vertical position. Although, does that mean this should be modulo piece height? Struggling to think. I think I need a wee. I will be back in a minute. Alrighty, I'm back. Okay, so we were trying to think through which of these should be width and which of these should be height. Kind of thinking maybe because they are the same. They're likely to be the same forever, that we just put an assert in to be like, these values should be the same, we don't care. Because I don't really want to sit thinking about this. But I also feel like I'm going to get it wrong. So assert piece width equal to piece height. That should do us right. And then I'll do D for dimension is equal to piece width. Yeah, there we go. And we can come in, and we can replace these with D. We'll do the same up here. And then we don't have to think about it for now. So that can all just be D. And we've missed one like that. So that gets us our column index, which, like we say, it groups by input row, and then it counts from top to bottom. So we go right to left. Our row index goes bottom to top. Year. And changes with each value. And then, yeah, updated piece filled. Right col index plus right row index times D equals val. There we go. So now we should be able to do a rotate one way and a rotate back. Beautiful. Cool. They currently have no checking on them though. Rotate one way, we rotate the other way. You know what? These are going to end up with shared stuff, right? But at this point here, we've got our new active piece. Before we can do the actual update, though, we're going to need to work out what our updated position will be, and then check if we collide. So I'll tell you what I'm going to do. I'm going to do a little checkpoint. Christ, I've changed a lot of files. I'm going to do a little just checkpoint commit work in progress piece rotating. Again, I know a lot of people don't like making a mess of your Git history like this, but I quite like having those kind of set points I can get back to if I screw a thing up. Sorry, I had a thought, and it's just gone. Yeah, I think it might be worth pulling these into a shared function and then just changing this logic. So let's have a think. We go rotate active piece as a procedure. That'll take a dir. Dir will be a enum clockwise or anti-clockwise. Right. And then the bit that is the same across the two is that's the same, right? And that's the same. And let me say in here, there's some to do, update, positioning grid. And there's a to do, collision detection. And the bits that are different, in here. If I go switch on dir, have case clockwise, have case anti-clockwise. And it's this filled business that I care about, right? So if I have rotate active piece, I want to say in here, really what this is going to be is get clockwise rotated filled array. Which will take in a piece, it'll return you a piece. Not even, right? It will take in a piece width by piece height bool. It will return you a piece width by piece bool. And we will call that input. Call that input. This is really the bit that cares about this, right? D is equal to piece width. That can drop. Case clockwise, updated piece dot filled is equal to get clockwise rotated filled array from our game state dot active piece dot filled. No? Just like that. And I think I prefer to keep them like this. You need a dot, or an enum that we're using anonymously. And then this one can go in here and say updated piece dot filled is get anti clockwise rotated filled array gs active piece dot filled. So that doesn't exist yet. Rotate active piece is going to need to take in a game state as a pointer to game state. Otherwise it doesn't know what the piece is, and it can't update anything. We just name this output. And we'll just make you output. How about that? Doesn't seem too bad, does it? And then we'll do the same kind of thing here. Get anti-clockwise rotated filled array. Which no longer needs to take all of that. It will take this times that, a bool. It will have an output, which is a this times that of bool. Doesn't care. For this in input, do all this stuff, get the output, and return. And it will also care about this. Cool. Then we come up to nya. That should work the exact same way. It'll break up here. Right, but we can now do something like this. And we avoid repeating ourselves for the collision detection. So rotate, rotate, all works. Very nice. Out of curiosity, what does it do if I do it right near the edge? It just overflows unhappily. And then works. Okay. Cool. So that feels like a win. Oh my goodness. Let's grab that. Update positioning grid is probably the next interesting bit to do. Collision detection, I think we can just steal from here, right? Grid width, grid width. Okay. Sorry, I think I'm just struggling again. It's a bit early. Let me do a quick checkpoint commit again. And I might go grab a coffee. I think I am fading. Tidier. So I'll be 1 minute. Okie dokie then. I think I might do the collision detection stuff now. And leave the update position stuff for when I'm feeling less tired. Because we're all just here having fun. And I'm not sure I'm going to do a good job of it. Whereas collision detection, I'm pretty sure we can just steal wholesale from our existing code. So maybe it'd be useful to just see what happens currently. Can I make a situation where rotation would be bad? We look there, if I rotate... Again, the positions are all a bit wonky. There, so that position should be able to come down and be fine, but that one shouldn't, right? So if I allow it to drop down a few more, and then I rotate, and they just overlap and collide. So that's the behavior we want to stop. We would like to say, if you're going to do that, then actually, can you not? And can you just, I don't know, like report that you would have collided and blow up. So we have some collision detection code. It's all down here. So I think what we're going to do is we're going to pull these out into a check, or I'm going to call it like is in grid. It's going to be a proc that takes a piece, turns a ball. Let's say in grid. Something like that. So we can take a piece. And I'm not sure what I've called grid. Looking in here. Yes, grid. The grid height by grid height ball. So grid will be in here. Grid width by grid height ball. We can do that. And then what I'd like to say is here. There is this collided bottom stuff. Maybe the check that you stay in the grid isn't actually shareable. One of them's going to care about collided bottom, the other isn't. Okay, that's annoying. The is-in grid is the simpler of the two anyway. What about this one? Check you don't overlap existing pieces. For val index in this. If val x is equal to the position plus, so we find the position actually in the thing. If y is outside the grid, ignore it. Oh. If grid y times grid width plus x is true. Updated pos. And then we have a collided bottom thing as well. Piss. Does this care about collided bottom? I don't think so, right? Because these rotations, I think, should update where you are, and then it should be the frame tick that drags you down and collides the bottom. So maybe we can't just copy paste that. What is there to do then? Maybe we do the position updating then. Is it even hard? I don't really know. I haven't thought about it too hard. How long have I gone for? Christ, it's been an hour. Okay, I might draw a line under this one and call this a good first video back, because I kind of wanted to make sure I did something so this didn't just sit rotting forever. But I always think I'm too tired, to be frank. And I've got work in a little while, so let's call this one here, and we'll handle these bits in the next one. I'll go stick a note in the README. Oh my god, I've already got notes in the README. Cool, okay. That's easy then. Get rid of that then. Cool. Good stuff then. Hey, we did something. It took us ages. So, apologies, I doubt this was the best video, but it was an accurate representation of what it's been like. So, hey, we'll call it a diary. Have a good one. I'll catch you next time.